Did you ever wonder how life on Earth all began? In this lesson, we will briefly outline the early conditions of life on land and in the atmosphere. We want to do this to get a better understanding of how evolutionary processes work. So, to start, let's begin with land. About 4.6 billion years ago, the Earth was essentially molten rock. There was no life on Earth. And this rock was essentially very hot. Ultimately, gravity helped to form this rock core, and after about 500 million years after that, a solid crust formed on the Earth's surface, and this crust was also extremely hot. After many, many years passed, oceans formed. These oceans formed because the Earth eventually cooled, and as it did so, liquid water formed on the surface. Science estimates that the first forms of life appeared on the planet about 1 billion years ago. Back then, atmospheric conditions were very different. It's important to remember that the atmosphere was composed of essentially 4 molecules: water, hydrogen, methane, and ammonia. Also, the climate was extremely different. There was a great deal of lightning, UV radiation, and there was little or no oxygen. These conditions helped us understand, potentially, or at least develop theories about how the first organic molecules were created. We'll talk about that in another video. But now I just want to talk very briefly about one hypothesis about how the first life on Earth, about 1 billion years ago, may have formed, and also what it may have looked like. So the first maybe life on Earth, according to scientists, might have been a heterotroph, something that needs food to survive, cannot produce its own food, so it's a consumer. And these heterotrophs, probably one-celled organisms, used other gases besides oxygen, which we obviously well use today, to synthesize energy. So remember, there was no oxygen on the planet. Eventually, heterotrophs were not consuming enough nutrients to survive because the environment didn't have enough to supply. They couldn't keep up. So ultimately, scientists proposed that there was a new mechanism, autotrophs, which are producers. These one-celled organisms ultimately, potentially made their own food. They did not look like plants. They were probably one-celled, but I'm making a plant-like structure here. And these early autotrophs evolved, and really importantly, evolved. Not only did this help heterotrophs and supply more food for heterotrophs, but autotrophs, their waste product was oxygen. So oxygen, as it turned out, became a very efficient way to produce energy in both autotrophs and heterotrophs. And these organisms, as oxygen developed in the atmosphere, ultimately thrived. And today, our atmosphere is made of, mostly nitrogen and oxygen. And our dominant organisms are oxygen-dependent organisms.